20 kg weight, and then you make homogenize and make size for extrusion. Then you do the extrusion process. What extrusion processing? Followed by that in that process you have to generate a process map where you can economically and technologically you can make the alloy into sound extruded rods. These alloys are, by the way, a little higher solute alloy. It's not so easy that you can deform in any way. So you have to have a processing window optimized for your alloy. So that these are all part of technology development. So you have to develop those things, and then we have to scale up the technology into industrial scale. Then you have to produce those things. This is the typical cycle of aluminum or that for that matter any alloy development. So once we have that, and then you see the microstructure, typical microstructure which will have, you can see the tiny black dots. Those are all strengthening precipitates which you have. These are all, by the way, precipitation hardening alloy. So you have a very nanometer size precipitates which will be uniformly distributed in the matrix, and this will give you a strength. And the optimization of distribution of both those precipitate volume fraction and size is by controlling the heat treatment and other processing parameters. In addition to that, how do you control grain size and all? This is all technology, part of the technology. How do you process the material to get the best out of it, to get the best combination of strength as well as ductility of the material. Okay, so this is how you process it. Now, one application we are in that process, although that application was driven by what you call strength dominated application. When we started work off with that one. Later on, we also worked on armor material, like tank body armors, where you want to resist the penetration of your armor penetrating ammunition. So typical alloys, but I am not showing you all the details, but I can tell you that there is a processing group. How many of you are aware of crystallographic texture? There is a probably in late 90s and 2000 there was a huge work on worldwide on crystallographic texture development. It's nothing but you know the grain structure, right? Now each grain of those has got a orientation of it in the 3D reference grain. So far we used to ignore because we didn't have the means to understand those things. You have to do earlier method is what? You have to do painstakingly TM. Each point you have to identify and what is what the diffraction pattern. You have to analyze that and get an orientation. Now there is a machine called EBSD, electron backscatter diffraction. It's now probably I don't know whether you have it in your institute or not. You certainly have in DMI. If anybody of you would like to see, you can come and see. Very beautiful instrument, which gives you, which basically operates on like your SEM, but it operates with diffracted diffracted electrons. So in addition to your the electron images, it gives you additional information of orientation. So you get a map of grain structure with orientation. Very beautiful. It's not the color means for the orientation of the grains. So that gives you a way to understand how that orientation of the grains will distribute. Now, so far we used to ignore those things. How the orientation develops. Now it is known that if you are deforming a material, depending on its processing route and its structure, it will develop some crystallographic texture, either strong, medium, or very strong. But so far we used to ignore. One example you will see, if you look at some of those your electric transformers, if you happen to see their the name block, you just see there, you will see that there will be something written CRGO steel. What does it mean? Cold rolled grain oriented. What is that grain oriented? It's basically crystallographic texturally oriented grains. So they make it in such a way that all the grains of that steel is oriented favorably so that it can be magnetized magnetized very easily compared to others. This is known from not from now. It is known from 1960s. But so far we used to not able to pay attention towards that because we didn't have the means to understand it. But slowly we are going into that paradigm that In addition to do processing, you must understand the texture. Now, why I am telling you so many things? A classic example is that if you look at this is the front side of a armor panel which is being fired from AK-47 rifle. This is typically called class 2 standard level of protection. From a 100-meter distance, if you fire with AK, you are aware of AK-47 rifles at this. So AK-47 rifle, if you fire, what is the protection? Now earlier, with the common, the natural, normal way of processing the things, this is the front side, this is the this is the front side, this is the back side. So there is a bulge on the back side. That means this is almost 30 mm thick plates. So almost going to cross. So this is first fire. If it makes a bulge, that means, see, terrorist is not going to fire one bullet. No. Oh, I'll fire only one bullet. No. He's going to fire at least 7, 8 if your targeting is at that point. So next point, what the problem is, if you are having a bulge like this, second fire it will deteriorate. If the second fire is nearby, even more dangerous. So third fire, fourth fire onwards, it will cross. But the same material, you now look at this microstructure here. You see the color? The color code is this. So this color, the green color is close to 110 orientation. This color is close to somewhere in between. Now see the distribution of the color by common hot rolling processes. Now we have fabricated some improved thermomechanical process whereby we increase the green factor. Right? Don't go into detail, just see the effect. This is the fire on the front side, this is back side, no bulge. And this penetration is almost 40% less than the previous one. This is the kind of same material, same processing, everything. Just tweaking of the thermomechanical process can lead up to this much of difference in properties. Can you think of these two behavior of these two materials? How much different it is? Price is same, every process is same, your manpower is same, processing is same, equipment is same. This much of difference it can make. So if you are ignorant towards the crystallographic texture development, you are nowhere. Basically, you will be ending up with that much. Whereas, if you know how to control the texture, you may end up with this much of improvement. This is how technological improvement is happening. And you have to be part of it. Now, there is another one, 2219 plate. This is 2219 means this is 2000 series alloy. So, aluminium copper type of alloys. Okay. So, when these alloys are, by the way, this missile, I will not name it, but this is one of the most talked about missile in probably last 2 years. This missile has been in say public domain for a right or wrong reason, whatever you want to think. There was a problem with the problem tag with both ISRO was facing and then our missile people were also facing. With the strength of the 2219 phase, which you need to have certain amount of strength. Now, 2219 alloy, I don't go into details, I'll just tell you the information. These alloys, when you are doing the heat treatment, it requires certain amount of, as you know, the precipitation strengthening. First, what you do, you take it to a solutionizing temperature. Make it a single phase alloy. Then you quench to make it a super saturated solution. Then you do the edging to make the precipitation in a uniform manner. This is the process, right? In this case, that before the precipitation, to enhance the effects of precipitation, you need certain amount of cold deformation. What it does, it introduces a lot of dislocation in your matrix. And those dislocations are high energy sites. It will activate more or it will facilitate more precipitation. So your aging time will be much less. It will be aging process will be much faster, and volume fraction of precipitates will be more. You get more strength. Now, in process of getting this, what we thought, this process, you see, there is a strength we are getting. Now, typical process calls for about 400 MPa strength is required for that application. Now, when you are doing normal, it is typically used in the stretching. After solutionizing, you stretch material Now, if you stretch a material for 7-8%, you are not getting no idea. But if you stretch more, what will happen? Because of the stretching, old stretching, you might generate some defects in the surface of the material, which is not good for the application. So our job is to introduce a deformation process which will restrict it to a 6-7%, but it will give you a desired amount of strength. What we found out that instead of doing only cold rolling, if you stretching, if you do a combination cold rolling plus stretching, it gives you a better say properties. I have not given you the last solution because that is strategic, which I am not supposed to disclose. That percentage breakup, how much you should do by cold rolling, how much you should do by stretching, and that is now industrially being practiced now. Okay, so that's how you the process is same. How you tweak your process to get the desired solution. Okay, so enough of all those things, and this is one of the examples of doing the infantry combat vehicles to develop those things. These alloys are earlier used to be imported, and there was this when you are talking about a armor application, your materials have three most important: strength, weldability, and there should be a corrosion resistance because it will be open air, exposed to air. First two properties are good, but not the high strength alloys are having weldability. So we have worked on that. We have a DMR developed alloy which will have a much higher strength with good fracture toughness and all other properties and with weldability. This is the kind of solution we need to offer to enable the designer to use the similar kind of alloy for our defense program. Okay, so this is how the research scenario is changing. Okay, so this is a summary of the alloys which are now so far for Indian defense. All these alloys used to be imported probably 5 years back. Now almost 80% of, you'll be glad to know that 80% of the Indian defense requirement is now being produced in India by all Indian companies. That is one big major boost to our Atmanirbhar Bharat program. Okay, these are the summarization of all those alloys that are being now produced in India. Okay, now let us see what is the problem with this. Now we talk about all these things. There are some issues with the development and an indigenization program. Now indigenization program means what? You get the alloy from outside, that component hardware. So whatever the alloy they uses, you just want to do some back calculation and trying to develop. In that process, you will end up with probably some hardware, 30 alloys, 30 different types of alloys. Now when you talk about now economic come into picture, probably you know about all those alloys, you can produce, but nobody will produce for you. You go to any big industries, they will tell that I need 200 kg of material, they will not even talk to you, not even look at you. Because their turnover is somewhere in one hit, they will produce 6-7 tons of material. So they cannot produce you for you 100 kg of material. So there should be a consolidation of demand. Then only they will be interested to produce all those things. That comes from consolidation of alloy. You cannot make one missile 30 aluminum type of aluminum alloy. So one alloy will be 30 kg. But from you, who will make it for you? Nobody will make it. Tomorrow you open up a company. Will you be interested to make 30 kg of alloy for one particular application? No, because it is not economically viable. That is how it is driven. So that is how we need to have it. Our design philosophy is based on their design. We need to rethink about the design philosophy, whether we can use one type of alloy which can cater the other needs. Now sometimes your metallurgy professor can also take classes in the mechanical, if he is that versatile. Now, in case of trans situation, you will always be wanting to have that professor in your department so that he can cater the other needs. Rather than one person, you only can teach physics.